Hi, I'm John Park. When we think about robots, a lot of us think about humanoid creatures like these. Now, this really can't act on its own. I have to give it commands from this remote. Well, today, we're going to build some robots that can act on their own. And they're so simple you can build them at home. Let's check out the first example, the simplest one of all, the BristleBot. This is a DC motor, a 9-volt battery, and a switch, and they're mounted to a scrub brush. These little bristles act like its feet. And by putting this weight on the shaft that's off-center, it's going to wobble, and that gives us its motion. Let's check it out. I love the way these move. Now, there are a lot of other Vibrabots that you can make. There's toothbrush ones that are tiny with a little pager motor in the end of the toothbrush. You can make art bots by putting paint on this and letting it scoot around on some paper. The sky is the limit. Now, I also think that this moves kind of creepy like a creature, and mimicking nature is really one of the best ways to build simple robots. Hey, get back there. Here's a whole herd of solar junk bots. They sit quietly, collecting light and charging up until they're ready to go, and then they twitch, roll, and spin. And they work great out in the sunlight. Here's how they work. They have a little solar cell on top, collects light, and turns that into a trickle of electricity that heads to this big capacitor, charging it up like a battery. Once it's charged, there's a circuit that sends all that electricity to the motors, and then it'll roll right off. The kind of junk bot I'm going to build is called a solar roller. And all you need to build one are some common electronic components and an old cassette player, as well as a solar cell. You can pull one of these from an old calculator, but I like these better. They're available from online retailers, and they just work great. Now, here is my cassette player. I got it for $1.41 at the thrift store. If you open it up and take a look, this is what I want, is this motor and pulley system. Here's one I've already removed, and I've trimmed away some of the excess parts so that I can use this as a wheel to put power to the road. I also need a front wheel for it. For that, I've got an old VCR, and I've pulled out this roller. If I attach that with a little bit of epoxy, I'll have a great chopper kind of look, just like this. Now all that's left is to build a power supply. I've soldered most of the control circuit onto my solar cell already. You can find a copy of the wiring diagram on our website. Now what's left is for me to solder the big storage capacitor to this circuit. This is what's going to capture all the electricity coming off of the solar cell. Now it's really difficult to hold all these parts and solder them at the same time, so I love to use a little vise like this and one of these third arm tools. It has these alligator clips that I can hook the component to and set it in place before soldering. So I'm going to make those touch right there. And now to solder this, I'm going to get my soldering iron. It's good and hot. A little bit of solder. And what you do is touch the two wires with the tip of the soldering iron so they get really good and hot. And then I'm going to touch the solder to it, and that's it. I've soldered the whole assemblage into the motor wires, so it's all hooked up and ready to go. I also used some poster putty to hook the cell on top. You could make it more permanent with some epoxy. So I'm going to check it out, put it under the light, and see how it goes. Oh, that's great. I love the way it pulses. Now, you can try out different components when you build yours to get different behavior, like a long charge and a fast shot right off the gate. You can also try out different components to get a different type of behavior, so have fun with yours. Here's a robot that explores and reacts to its environment. It's called a Roomba, and it's a robotic vacuum cleaner. Now, this doesn't have a floor plan in its brain. Instead, it just reacts to walls and other obstacles by hitting them with the bumper, turning, and getting out of trouble. We're going to use this same idea to build our next mini robot. It's called a BeetleBot, and it's a really cool insectoid robot. Now, this one uses no electrical components. It's made up of a battery holder and a couple of batteries, 2 motors, and a couple of switches, and a really clever design by a maker named Jerome Demers. Now, these motors, you can pull them out of old toys or even a toothbrush. They're a bit hard to get into, but they're really good motors. And the thing I love about these switches is that when they bump into something, they close. Now, for the body of the robot, I'm going to use some of this great perforated metal sheet. You can get this from a metal supplier. I'm going to cut a couple of strips out of this and use them for the body of the robot, as well as the legs of the robot. They'll be mounted here like this. Now, just like the Roomba, when they encounter an obstacle, they'll turn and back up to get free. I've mounted the motors on this little cross piece, and then I've bent this down at a 45-degree angle. The motors are held on with some electrical tape, and they're going to act like little wheels that drive the bot around. Now, so that they can get some traction, I've put some heat shrink tubing on the ends of the shafts to act as little tires. Now, this is a pretty easy way to add some friction here. What you do is take some of this heat shrink tube, cut off a little piece, put it on the shaft, and then heat it up. You can use a soldering iron, the side of a lighter, or a heat gun, even a hairdryer. And I build that up by putting 3 or 4 layers and even going up a diameter in heat shrink so that I get a nice fat tire. I mounted the 2 switches onto the body. And this is one of the reasons I love working with this perforated metal. Using a couple of paper clips like staples, I get a really precise and secure connection between those. Now I've got another paper clip that runs through the battery holder. I slide on the crossbar with the wheels and the body of the bot. Now I'm going to fold those over, trim off the excess, and then I'll be ready to solder it together. I finished soldering everything together, and I put a couple of batteries in. I'm also using an old LED as a back wheel so he doesn't drag when he moves. Now, for these little switches to be more sensitive, I want them to have antennas like a bug. So what I did was unfolded a couple of jumbo paper clips and attached them to a little terminal end. This is what it looks like when I'm finished. And I'll be able to slip this right over the end of the switch and then test how it works. So that you can see the wheel. I'm going to place this here. Now, when I flip the switch, he's going to roll forward. When he bumps into something with his antenna, he goes backward. All that I have left to do is attach the other antenna, and then we'll go test him out. I'm going to build a little obstacle course for my BeetleBot to try out. So I'm going to grab a couple things from the shelf here that he'll bump into, and he'll either back up or turn to get out of trouble. So bring him back here, turn him on. Off he goes, pretty straight. And there, he hits one of his antennas on those obstacles and turns the opposite wheel to get out of the way. This is great. Oh yeah, that's just perfect. He moves just the way I hoped he would. Simple robots like this are just the beginning. There's a whole world of advanced robots out there you can build, like these line followers, or sumos that battle, or even this incredibly sophisticated outdoor navigation robot. All of these were built by the Twin Cities Robotics group, and there's probably a group like them near you. So meet up with some people, learn some more, and build some robots. I'm John Park, and I'll see you next time on the Maker Workshop.
Major funding for Make is provided by Geek Squad.